Alright, welcome a Chaks solution. Alright, so this is inequalities. So we are going to be dealing with modulus inequalities here. Alright, so we are going to be solving modulus inequalities using algebra method here. So let's go here. So modulus of x is equals to k, where k is greater than or equals to 0. So this can be referred as the absolute value of what? Of x. So this one is the distance from the origin to a point x, which is what? K units here. So let's see how it looks like on the number line here. Alright, so you can see we have the number line and we have the origin. So moving from the origin to a point k here, which is on the x-axis, and moving from the origin to another point here, which is minus k, which is on the x-axis. So the distance here to the point k will be equals to k, and the distance from the origin to this point minus k will be also equals to k here. So the possible values of x here is x is equals to k, or x is equals to minus k here. So the absolute value of x is equals to k is x is equals to k, or x is equals to minus k here. Alright, so let's go to this one. Then modulus of x less than k here, we're just looking for the distance from the origin to a point x, and that distance should be less than what? Should be less than k here. So let's see how it looks like on the number line here. Alright, so you can see we have minus k and k here. So moving from the origin to a point k here, it's equals to k units. Then moving from the origin to a point minus k is equals to k units. But moving from the origin to a point that is maybe here, the distance will be less than k units. Then moving from a point from the origin to a point here, which is somewhere here, the distance will be less than k units. So x will be lying in this range. So x will be lying in from minus k to k here. So which means modulus of x less than k can be written as minus k less than x, or less than k here. Alright, so let's go to the last one here. Then modulus of x greater than k. So we need the distance from the origin to a point x, and that distance should be greater than what? K units. So on the number line we have minus k and what? And k here. So moving from the origin to a point which is beyond k, maybe somewhere here, the distance will be greater than what? Will be greater than k units. Then moving from origin to a point which is beyond negative k here, the distance will be what? Greater than k units. So what it actually means, it means x will be lying in the range of x less than what? Minus k here, or x will be lying on the other side where x will be greater than what? Greater than k. So which means modulus of x greater than k, it implies that x is greater than k union x less than what? Minus k here. Alright, so let's go to the example and see how it go about here using this concept to solve modulus inequality here. Alright, so let's go to the first example. Solve the inequality modulus of 2x minus 1 less than 3 here. So in this case, I'm going to be using this facts, which is method 1, and I also use another method, right? So modulus of 2x minus 1 less than 3. We are just interested in this result. Modulus of x less than what? Well, less than k. So it's minus k less than x less than k here. But in this case, we are now replacing with our function 2x minus 1 here. So which is now minus 3 less than 2x minus 1 less than 3 here. So now we want to solve this inequality here. So you can take this minus 1 to the other side here and add on 3. Then minus 1 to the other side here and add on minus 3 here. So we are going to have minus 3 plus 1 less than 2x less than 3 plus 1 here. So this will give us minus 2 less than 2x less than 4. Then we can divide by 2 here. So dividing by 2, we are going to have minus 1 less than x less than what? Less than 2 here. Alright, so that will be our solution here. Another way that you can do, you can take your inequality from minus 3 less than 2x minus 1. Then you stop there, you solve separately. Then you also take the other part, which is 2x minus 1 less than 3, also solve separately. Then you combine the answer to have minus 1 less than x less than 2 here. Alright, so let's go to method. Alright, so let's go to the second method here. Alright, solve the inequality modulus of 2x minus 1 less than 3 here. So our method 2, first thing is to solve the corresponding modulus equation to find the critical values. Then the second step is to arrange the critical values using the inequality boundaries or region. Then the third step is to test the boundary to see the true region here. Alright, so let's go here. Modulus of 2x minus 1 less than 3. So the corresponding modulus equation that we can have is modulus of 2x minus 1 is equals to what? Is equals to 3. So we know that the absolute value of a function is equals to 3. This can be written as 2x minus 1 is equals to plus or minus what? Minus 3 here. So we can solve this equation right, for x here. So we are going to have 2x minus 1 is equals to 3, or 2x minus 1 is equals to minus 3 here. So we solve for x. So we are going to have 2x is equals to 4, or 2x is equals to minus 2 here. Then x is equals to 2, or x equals to minus 1 here. So now we now have these two critical values. Our critical value is x is equals to minus 1 and x is equals to 2. So the next thing now is to place these critical values using the inequality boundary region here. So we start with the smallest one here. So it's x less than minus 1. Then you combine the smallest one with the next one. So it's minus 1 less than x less than 2. Then x greater than what? Greater than 2 here. So now we are going to be testing this first region, the second region, and the third region to see which is a true region here. Alright, so testing. So we'll be testing using this inequality that we have here to test our region. So the first region that we are going to be testing is the region of x less than minus 1. So we are going to take a number which is less than minus 1. So the number which is less than minus 1, you can use x equals to minus 2 here and substitute into the inequality here. So you are going to see that we are going to have modulus of negative 5 is less than what? Less than 3 here. So the absolute value here, you can see it just become a positive here. So it's 5 less than 3. So 5 less than 3 is a false statement. So which make this region to be what? To be false. Then we go to the next one here. We are testing for minus 1 less than x less than 2 here. So we are going to take a number between minus 1 and 2 here. So it's x equals to 0 and place it into the inequality here. So we are going to see is minus 1 under the modulus less than 3. So 1 is less than 3 here. It's a true statement. So which makes the second region to be true here. Then we test for x greater than 2, the last region that we have. So we take a number greater than 2 here. We can use x is equals to 3. So we substitute. So we are going to have modulus of 6 is less than 3 here. Then we have 6 less than 3. So this is a false statement. So this makes region to be false. So now we are left with this region. So that will be our set of solution here. So the set of solution is minus 1 less than x less than 2 here. So remember, when you are testing here, we just say you can just press your calculator and you'll be writing true, false on your boundaries. Just pressing on the calculator here. Alright, so let's just go to the next example. Alright, so let's go to the next example here. Solve the inequality modulus of 1 minus 3x is greater than or equals to 4 here. So we're going to use method 1 here. Alright, so we know that modulus of 1 minus 3x greater than or equals to 4 here. We need to recall this result. Modulus of x greater than k can be written as x is greater than k union x less than what? Minus k here. So that's the same thing that we are doing here. So it's 1 minus 3x greater than or equals to 4 here, or 1 minus 3x less than or equals to minus 4 here. So we are going to be solving these two equations here. So I'm going to start with the first one here. So this is minus 3x greater than or equals to 4 minus 1. Then the minus 3x greater than or equals to 3. Then we divide both sides by minus 3. But remember, when you divide with minus 3 here, the sign of the inequality sign will change the face of direction here. So we're going to have x less than or equals to minus 1 here. So the moment when you just divide with the negative, the inequality sign will change the face of what? Of direction. Alright, then the next one here, 1 minus 3x less than or equals to minus 4. So we have minus 3x less than or equals to minus 4 minus 1 here. So we have minus 3x less than or equals to minus 5. Then we divide with minus 3 here. Then the inequality will just change the face of direction. So it's x greater than or equals to 5 over 3 here. So now our set of solution is x less than or equals to minus 1 union x greater than 5 over 3 here. Alright, so method 2, we have modulus of 1 minus 3x is greater than or equals to 4. So we are going to be finding the critical values using the corresponding modulus equation. So our corresponding modulus equation is modulus of 1 minus 3x is equals to 4. So this is 1 minus 3x is equals to plus or minus 4 here. So we are going to have two equations. 1 minus 3x is equals to 4 or 1 minus 3x is equals to minus 4. So if we solve here, we are going to have x is equals to minus 1 or x is equals to 5 over 3 here. So these are the critical values that we have. So now we can arrange our critical values on the with the boundaries here. So we are going to start with the smallest one here. So it's x less than minus 1. Then you join minus 1 with the next critical value. So it's minus 1 less than x less than or equals to 5 over 3. Then x greater than 5 over 3 here. So the next thing is to test these regions here. Alright, so we are testing using this inequality here. So it's a modulus of 1 minus 3x greater than or equals to 4. So we are testing for x less than minus 1 here. This is our first region. So we are going to use minus 2. So if we put minus 2, we are going to have modulus of 7 greater than 4. So 7 is greater than 4. This is a true statement here. Alright, so which makes this a region of x less than minus 1 to be true. Then now we are testing for the next region, which is minus 1 less than x less than 5 over 3. So we need a number between minus 1 and 5 over 3. We can use 0 here. So we test with 0. So we are going to have 1 greater than or equals to 4. So 1 greater than or equals to 4 is 1 greater than or equals to 4 here. So it's a false statement here. So we should make this region here of minus 1 less than x less than 5 over 3 to be false. Then we test for the last region, which is x greater than or equals to 5 over 3. So we need a number which is greater than 5 over 3. We are going to use 2 here. So we use 2. So we are going to have modulus of minus 5 greater than or equals to 4. So the modulus will just remove the negative here. And we are going to have 5 greater than or equals to 4 here. So which will make our last region to be true here. So which means the set of solution that we have is x less than or equals to minus 1 union x greater than or equals to 5 over 3 here. Right, so thank you for watching the video. See you in the next